Hello everyone, welcome back. In last lecture in heap management, we have discussed about how free list maintain list of free blocks using singly linked list and doubly linked list. So in this lecture, we are going to discuss about three different techniques which are used in allocation. In that the first technique is first fit technique, next is best fit technique, and third one is next fit technique. So these are the three techniques which are used for allocation of memory for different processes randomly. So let's see how these three techniques works. So friends, before going to the actual problem, first we'll see what is the problem that we're going to have discussed in this example. We have three free blocks of memories. First one is 200 MB block is free. Second free block is 170 MB and third free block is 500 MB. So we have three free blocks of this size. First one is 200 MB, second one is 170 MB and third one is 500 MB. Now suppose that in process Q, three new processes have arrived. First process require 100 MB of memory, second process required 50 MB of memory and third process require 400 MB of memory. Now this is the responsibility of operating system that it has to allocate memory for newly arrived processes. So as we have discussed, we will begin our discussion with first fit technique. Here we have free list header which is using singly linked list to maintain list of all free blocks. The first free block is of 200 bytes, second free block is of 170 bytes and third free block is of 500 bytes. So as we have discussed, we have three different processes which are newly arrived in a queue. The first process require around 100 MB of memory, 100 bytes of memory. Second process required around 50 bytes of memory and third process required 400 bytes of memory for their processing. Now let's see how first fit technique is used by operating system to allocate memory for these three different processes. So in first fit technique, operating system give higher priority to the first free block. Now consider that we have the first process in a queue which require 100 bytes of memory. So operating system first give priority to the first free block. It check whether 100 MB can be fit into the first block or not. If it can be allocated to the first block, it will definitely use the first block. Now for example, consider that these 100 bytes have been allocated in this first block. So here we will be remained with 100 bytes of free space. So next process require 50 bytes for processing. Operating system once again give highest priority to the first block itself, which is 100 bytes remained. So it will once again allocate 50 bytes from this. So we'll finally be remaining with 50 bytes of free space here. So this is the first fit technique. Then next one is 400 bytes. So it will check. We have here only 50 bytes remained. So these 400 bytes cannot be allocated in the first block. So operating system will check the second block. So these 400 bytes cannot be allocated in 170 bytes as well. So it will check the next block which is of 500 MB. So we can see here 400 bytes can be allocated to this block. So operating system has allocated these 400 bytes into this, and finally we have 100 bytes of memory remained as a free. So this is how first fit technique works. So next we will discuss about best fit technique used by operating system to allocate memory for different processes. So we will consider the same scenario here. We have three free blocks, 200 bytes, 170 bytes and 500 byte. Best fit technique use smallest memory which can be allocated to the process and minimum amount of memory can be wasted. So it give priority to the smallest available memory in the free list. So check now, if the first process in a queue require 100 bytes of memory, it will first check the first block. 200 byte of free memory it have in a first block. So it can allocate 100 MB to the 200 MB easily. But we have second block 170 bytes. If we allocate this 100 MB to the 170, we will be remaining here with 70 MB, and here in the first block we will be remaining with 100 bytes of memory. So which one is the smallest here? 70 is smallest definitely. So it will definitely choose the second one for allocation. If we allocate this 100 MB to the third block, it will be remaining with 400 bytes of memory. So it won't select third memory block for the allocation. So here the second block is perfect for best fit. So as we can see here in best fit, we have allocated this 100 bytes to the second block. So if we allocate these 100 bytes to the second block, we will be remaining with 70 bytes of memory remained. Next process require 50 bytes of memory. So as we have discussed, these 50 bytes can easily allocated in these 70 bytes. So as we have discussed, these 50 bytes will be allocated to second block itself. So we are remained with 20 bytes of memory now, and last one is 400 bytes of memory is remained now process. So here we can see that the only process which is greater than 400 is only memory block which is greater than 400 is the third block. So we have to allocate these 400 bytes to the third block. So this is the best fit technique, how it works. So next we will have discussion on next fit technique. Operating system, when using next fit technique, every time it selects next free block for new allocation. Let's see how it works. For example, the first process which requires 100 bytes of memory, it will allocate in a first free memory area, that is 200 was the first free block. So it allocate 100 bytes from that, and remained bytes are 100 MB. Now next, second process, for second process operating system select second block and not the first block, even though 100 bytes are remained here, and we can allocate these 50 bytes easily here in this first block, but operating system select next free block for the allocation. So as per next fit rule, it allocate the second process to the second block. So 50 bytes are allocated here and 120 are remaining bytes. For third process, it select the next free memory block, that is 500 MB, and it allocate these 400 bytes into these 500 free block of memory, and we finally remained with 100 bytes of memory. So this is how these three different techniques are used by operating system for allocation of newly arrived processes. So here we conclude our today's lecture. In next lecture we will discuss about continuous and non-continuous memory allocation. Thank you.